This is David Hillier here of the University of Strathclyde, and I will be giving a small 15-minute video on time value of money. And this particular video will focus on the single period case. I've set up my screen so that on one side, the left side, I've got the slides, and then on the right hand side I've got Excel, and I'll be doing the calculations that I discuss on Excel, so that you'll be able to see how this is done using a spreadsheet. The slides come from my textbook, Corporate Finance, and this particular chapter is chapter 4, and the title of that chapter is Discounted Cash Flow Valuation. My approach here will be just really covering the early sections of this chapter, but later videos will go through other material as well. So this lecture is about valuation, and it is only the single period case that we'll be looking at in this video. So it's a very introductory lecture, but it's incredibly important because the material that I cover here is the foundation of the majority of things that you will meet in your finance studies. It really is important to make sure that you understand these techniques, and also I would advise you to attempt the end of chapter questions in chapter 4, and just to make sure that you understand these methods. I find that if students don't put the time in just now, then they do struggle later on once we take the ideas for granted. This first example, sometimes it's easier to explain time value of money concept with an example, but there's a number of ways. I would like you to think just on an abstract level. If you were to talk to a friend and the friend said to you, right, okay, can you lend me money today? And I promise you I'll give you back the money that you gave me, plus an amount to compensate you for, basically the loan. Then you would then be engaging in a decision that offset investment or consumption today with investment or consumption in the future. Now, how would you explain that? Well, if you've got £100 today, you could decide to spend all of that £100 today, or you could decide to invest £50 and consume £50, or you may decide to invest all £100. That decision that you make today has an impact on the amount of money that you have in the future. So if you decide to spend all the £100 today, you're not going to have £100 in the future. If you decide to invest £100 today, then you will get £100 that you've invested plus an amount which is your compensation for that investment, and we call that your rate of return. If it's risk-free, if it's money that you put into a bank account, then it would be an interest rate. If you decide to spend £50 today and invest £50, then 1 year's time you will get the £50 that you invested plus an amount which is the return on your investment. And we call that, that's really an investment consumption decision. The amount that money grows by in the future we call the rate of return, and we also call it the interest rate. And you then, once you take that interest rate into account in your decision, then it's not just a simple case of saying, okay, I invest £100 today and I get £100 in the future. But it's actually, the decision becomes slightly more complex in that you invest £100 today and you'll get £100 plus an amount in the future. And it's that extra amount that determines whether that investment is worthwhile or not. And finance and investment decisions, really, that's what you focus on. You focus on whether the amount that you get from your investment is enough to compensate you for going without the money that what you would have spent today. Now, this first example here on the slide, it's a very simple example. You've got land. Keith Vaughan has land and was offered yesterday £10,000 for that land. Now, you could accept that or not, and we've got here in this example that Keith decided to accept it, but then another individual offered a greater amount. That greater amount was 11,424. But you're not going to receive it just now. You're going to receive it 1 year from now. So you're comparing yourself. You're comparing two particular investments. So you've got the one 10,000 today, or a potential 11,424 in the future. Now, if both of these cash flows are risk-free, that is, that you'll definitely get the money, then which offer should you choose? Now, what I'm going to do is I'm just going to try and put this on a spreadsheet just to give you an idea. So we've got investment. We'll say investment. We'll say project A, and in project A you receive £10,000 at time 0. So you get time 0. And you're receiving £10,000 at time 0. And then project B, you're going to receive £11,424 in time 1. And what you're wanting to do is you're wanting to compare that. Now, you might say, well, how do I do that? That's really, even looking at this, it's quite complex. Well, what you're really doing is you are trying to say, well, okay, if let's say I was to receive £10,000 today, how much would that £10,000 grow to in 1 year's time? And then you're starting to think, well, okay, how much would it grow to? What does that mean? Well, it means that if you had that £10,000 and you put it into a bank account, now this is risk-free, so you assume that the bank is risk-free, then how much would that grow to? So at the moment we get maybe 5%. Let's assume that you're getting 5% on bank account, a savings account. And what you would do is you'd put the 10,000 in to the account. You would get 5% on that. That's the interest rate. How much would that grow to? Well, let's just look at this. I'm going to change the colour to blue. Okay, so what I'm going to say is I'm going to say equal to 10,000 multiplied by 1.05. And it grows to 10,500. So if you were to receive 10,000 today and you put that money into a bank account, after 1 year, if the bank account's offering you 5%, you would have 10,500. Now, what you're doing then is saying, well, okay, if you chose project B, you would be given 11,424. So clearly, if you can only invest the 10,000 today at 5%, then it means that project B is giving you more money. So with this particular offer, you would choose project B. You would actually reject the 10,000 today, and you would accept the offer to get for the land 11,424. Let's assume that you find another bank account that gives you 10%. So I've increased the rate. I've just multiplied the amount by 1 plus the rate of interest. Even then, with an interest rate of 10%, you're still not getting 11,424. So with this particular example, you would say that project B is better. If you don't know the interest rate, there is no way that you can decide with any certainty whether project A or project B is better. And that's, as a very simple example, that's time value of money. Now what I'm going to do is I'm going to just just now I'm going to add in some symbols. I'm going to say PV is equal to present value. I'm going to say FV is equal to future value. And I'm going to say R is equal to the interest rate. So what are these cash flows like? Well, you could actually say, well, if we wanted to equate or find the interest rate that equates project A, the 10,000 with project B, so that you're indifferent between the two projects, then you would say, well, the value PV multiplied by, in fact, I'm even going to say PV plus PV times R. That this part here is the interest that you earn on the original amount, must be equal to the future value. Yeah, because if we wanted to make these the same, then we would set R to be such that the value in this cell is equal to the value in that cell. So what is that? Well, it's PV times 1 plus R, because I'm just taking PV out of that. And we're saying PV times 1 plus R is equal to FV. Right, okay, now that's a fairly straightforward thing. And then we say, okay, I'm going to even take it further. So I want to find R here. Right, well, if I'm wanting to find R, then I would do 1 plus R is equal to FV divided by PV. See what I've done? I've just divided both sides by PV. So then R is equal to FV divided by PV minus 1. Oops, what have I done here? Okay. Okay, I've just put a little, if you notice, if you want to show this, then you just put a little apostrophe up there. And that you'll be able to get that. So we've now got a formula that we can use to work out the rate of return on the bank account, the interest rate on the bank account that would make us indifferent between A and B. So let's go with the figures that we've got. So R is equal to FV, which is 11,000, divided by PV, minus 1. 0.414. And we can put that into percentage. I'm going to format this cell so that we've got 2 decimal places. 14.24%. So for us to be indifferent between project A and project B, the bank account would have to pay us 14.24%. If we don't have 14.24% as a bank account, then if it's less, then you would choose project B. But if the bank account gave you more than 14.24%, you would choose project A. And I'm going to just give you an example. Let's just go back up here. Let's put in 14.24. So I've got 1,424. So that's where they should be the same. And look, you've got 11,424 and 11,424. Let's go above. Let's make it 15%. You're now making more money. So the time value of money is this. And I think it's just a nice little example of looking at this, and actually leads us to some of our primary or foundational formulae for time value of money. And this is a single period case, but what we can say is the future value is equal to PV times 1 plus R. So if we've got an amount today, then, and that's PV, we know the interest rate, we know how much that money can grow to. And then we're going to actually do another one, which is, and express it differently, that we can actually say, if you know an amount in the future, then what is the equivalent amount today? Well, it's just PV is equal to FV divided by 1 plus R. And I want you to remember these formulae, because these formulae are exceptionally important. And this one as well, actually. your course, you might be asked to know these, or you might be given this in a formula sheet. But these are the very foundations of time value of money. So let's just go through some of these. So I've already covered this one. If we look here, I've used a savings rate of 12%. So let's just put the 12% in. And we get 11,200. So if you were to invest in a bank account to 12%, it would grow to 11,200. You have that here. It's not as good as 11,424, so you would say that Project B is better. We could actually discount it back, and we could discount this back to times 0, and we would use this formula here. So I'm just going to use that here. Let me just put that here. So it's equal to, the present value is equal to the future value divided by 1.12, because we're using 12%. That comes out to be 10,200. So we're comparing 10,000 today for Project A with 10,200 for Project B. Again, Project B is better. And with present value, future value, it doesn't matter if you decide to take one forward in time, so take the present value forward and compare with the other future value, or you take the future value and bring it back to today to present value. You're comparing like with like. And comparing like with like, you're always going to get the same outcome. And it's up to you how you want to approach this particular type of problem. So here's the formula. And what I've done here is I'm substituting the cash flow at time 1, which I've called future value, and I'm calling it C1. Now, why am I calling it C1? Well, I'm calling it C1 because the cash flow, the future cash flow, occurs at time 1. And, I'm going to expand on that. For us, and for our very special case just now, I've just called it future value. But in a future video, we will be looking at this in more detail, and we will be expanding the formula so that we have a lot more complexity. R, we talked about R being the interest rate. When you're bringing a future cash flow back into present value terms, we sometimes call it the discount rate. So in this video, I've called it the rate of return, I've called it the interest rate, I've called it the discount rate. All these terms are interchangeable. The interest rate's always with respect to a bank or some type of loan. The rate of return is usually when you're dealing with present value and you're looking forward. And if you're looking forward, if you are in time 2 or time 3 and you're looking back, we call it the discount rate. Okay, so let's go on to another example. In this other example, you have a financial analyst and looking to invest in a piece of land that costs 85,000 euros. So let's just move over here. Okay. Now, next year the land's going to be worth 90,000. So we've got PV is equal to 85,000. I'm not going to put the currency in, I'm just going to put the numbers. Next year, now let's call it C1. Right, let's just, because given where we were on the slides, it could be called future value. So we could say future value, which is equal to C1, which is equal to 91,000. Okay, so your return on this investment, you invest today 85, you're getting 91 1 year from now. You know that instead of investing in that land, you could put the money into a bank account, and the bank account would give you 10%. So you're then asked, should you invest in that land? And I'm going to approach this from two ways. I'm going to say, let's take it forward. Okay, so PV times 1 plus R, which is equal to C1, is equal to, let's say, 85,000 multiplied by 1 plus 10%. Now notice this is 10%, which is equal to 0.1. A lot of students, they sometimes put 10 in here. And we've got 93,500. So if we invest in the land just now, we get 91,000 in the future. But if we compare that to investing in a bank account that gives us 10%, then you can see that in actual fact the land isn't as good an investment as investing in the bank account. That would tell us that we shouldn't invest in the land. Why? Because we could get a better return by putting our money into a bank. Let's do it the other way. What we'll do is we'll take the future value, let's just call it C1, discount it back to today. That's equal to PV. It's 91,000 divided by 1 plus 10%. And you're given 82,000. So the equivalent value of that today to you when you have the opportunity to invest 10% in a bank account is actually only 82,000. So you compare that to what you've got today, and what you've got today is 85,000. So that investment in the land isn't a good investment. You should reject it. Here we are. So these are the figures. You invest today 85,000. You get 91,000 back. The present value of that investment is 91,000 divided by 10%, 1.1. That's what we did here. And it gives you 82,727. That's worth less than what you have just now. It's worth less than what you've invested, so you should not invest in that project. Okay. Now, you might say, well, if we look at this particular example, the present value of 91,000 is 82,000. So how much are we worse off, or how much are we better off? Well, what you do is you can then say, well, and I'm going to just, again, write it out slightly different. We've got C0 and you've got C1. Okay. And these are the actual cash flows. So we are investing 85,000. Now, notice what I've done is I've got a negative value for an outflow and a positive value for an inflow. What we're getting coming in is 91,000, and that's positive. So what are the present values of these cash flows? Well, the present value of a cash flow today is simply that cash flow. The present value of the cash flow that occurs in 1 year is equal to that value divided by 1 plus, in this case it's 10%. I'll just click on that. And you have the 82,000. So that's the present value. What's our net present value? What is that? Well, the net present value, and we'll call it NPV, is equal to minus 85 plus the present value that we get in year 1, and it's minus 2272.73. So given that is lower than the initial value, you would reject the project. And this is actually one of the main investment appraisal methods that you get in finance. We call it net present value. And you choose a project if the net present value is greater than 0, and you reject the project when it's less than 0. You'd be indifferent if it was equal to 0. And this is a formula. So net present value is equal to the cost, notice the negative sign, plus the present values. Now, this is just the next case, and what this is it takes the previous example where you are certain about the future value, you're certain because it's a bank interest rate, and it extends that into cases where you're not certain, right? And so it's slightly different. It's the same approach, but it is it's a different way of looking at it. So what you've got here is you're now thinking of buying modern paintings, and there's a Picasso that the manager wishes to purchase for 400,000, and then they're going to sell it after 1 year. Now the interest rate is 10%. Now you don't know how much this painting is going to be worth in 1 year, so you expect it to be worth 480,000, but you're not certain. So instead of being certain, you're now dealing with uncertainty, and we talk about expected cash flows. And you can see in the little diagram here that you're certain about the payment, it's 400,000, but you're uncertain about the income that's coming in. Okay, so if you're uncertain, you need to make a decision on what should that discount rate be. Well, you know that if it was certain, that is, if you put it into a bank, the interest rate would be 10%. Okay, so if you wanted to discount the cash flows at being certain, you've got C1 is equal to 480. It's a certain interest rate of 10%. So what's the value today, PV? The value today is equal to 480 divided by 1 plus 10%. And we get 436,064. Okay, now compare that to how much you would have had to invested in the project. So if I go up here, you're going to invest 400,000. So if you're going to get 480, then that's actually a good investment. Why? Well, what's the NPV? Let's look at the NPV here. The NPV is equal to the initial investment of 400,000 plus the present value. So you're actually making or increasing the value of your wealth. But we're talking about expected cash flows. So going back here, let's assume that it's actually going to be really risky. You don't know. And given that the interest rate's 10% with risk-free, you actually come up with a decision that in actual fact, the more appropriate discount rate is 25%. So if you do 25%, now it's the same formula, you find that the present value of that is actually 384, which is less than 400,000. And in actual fact, your NPV is minus 16,000. So that would actually tell you that you shouldn't invest in the painting. And this can actually take a lot of students by surprise, because they get concerned at this and they say, well, wait a minute, I've paid 400, I'm expecting to get 480, but you're telling me that in one case it's acceptable, in the other case it's not acceptable. Yes, I am, because it's down to risk. The riskier the cash flows that you'll receive in the future, the lower the value that these will be today, because you've got to discount that risk. You've got to discount the cash flows according to that risk. And that is a key finding in finance, and it's a key finding in time value of money. We'll go into this in a lot more detail in future videos. I apologise that this video took longer than 15 minutes, but it's worthwhile. So thank you very much.